All right, let's get right into it. If you spent any time with Java, you have definitely seen the keywords static and final pop up all over the place. But here's the thing. They're not just some boring piece of syntax you have to learn. Nope. They are seriously powerful tools that pro developers rely on to build secure, blazing fast, and really well-designed backend systems.
So what's the big deal, right? Why are these two little words so absolutely fundamental to Java? Well, understanding the answer to that question, that's the key. That's what takes you from just writing code that works to actually engineering software like a pro.
And trust me, we're not talking about some abstract textbook theory here. We're talking about real-world, high-stakes stuff. Things like managing your app's configuration, handling database connection pools, creating security constants that can't be tampered with. Static and final are the bedrock for all of it.
So here's how we're going to break it all down. First, we'll get to know static, our go-to class-level tool. Then, we'll meet final, which I like to call the immutability shield. After that, we'll see the magic that happens when they team up. And to cap it all off, we're going to pull back the curtain on the JVM startup sequence, the master blueprint for how it all comes together.
All right, first up, static. Let's think of this as the foundational building block. It's how you share resources and behaviors across your entire application, and it's super important to get this right. Okay, so what does static actually mean? Here's the most important thing to remember. Static stuff belongs to the class itself, not to any one object you create. The JVM loads it into memory one single time, and that one copy is shared by everything. Think about it like this. If you have 1,000 user objects and they all need the same API key, you don't want 1,000 copies of that key floating around in memory, right? With static, you get just one. That's a huge deal for efficiency.
And here's a perfect real-world example, an app config class. See how app name and max threads are marked as static? That means these values are loaded once and only once when the app config class is first needed. You never have to create an app config object to use them. You can just write appconfig.appname from anywhere in your entire codebase. So simple.
And that last example really drives home the benefits. It's crazy efficient because you're not wasting memory loading the same stuff over and over. It gives you easy global access to constants, and it's absolutely essential for things like utility classes and for bootstrapping entire frameworks, like when you need to load a database driver before you can do anything else. Here's another classic example, a utility class. Just look at this password util. Does checking if a password is strong or hashing it depend on any specific user object? Nope, not at all. These are pure stateless functions, so making the method static is the perfect design. You just call password util.hash directly. It's clean, it's simple, and it just makes sense. Okay, moving on. Let's talk about our next keyword, final. I want you to think of this one as your shield, your immutability shield. It's a tool for writing code that's way more safe, secure, and just plain predictable. Now here's where it gets interesting. Final isn't a one-trick pony. It's actually pretty versatile, and its meaning changes depending on where you put it. There are 3 totally distinct ways you can use it. First up, if you make a variable final, it's basically a constant. Once you assign something to it, its reference can never, ever be changed. Then you have final methods. This is like locking down a piece of logic, telling other developers, hey, you can't override this in a subclass. And finally, you can make an entire class final, which means nobody can inherit from it at all. This is a huge move for security. Let's look at a super important security example, a JW token. By making the whole class final, we stop anyone from creating some kind of malicious subclass that could mess with how the token works. And by making the value field final, we guarantee that once a token is created, its value is set in stone. It is immutable. It cannot be changed. This is how you write safe, predictable code you can trust.
So, we've met static and we've met final. But what happens when these two meet? Well, this is where the real power is. This combination creates one of the most important patterns in all of Java development, the true constant.
And here we go, the pattern in action with a database connection pool. The static keyword makes sure this pool is created exactly once for the entire application, and final guarantees that the reference pointing to this pool can never be changed or reassigned. You've just created a single, unchangeable, globally accessible resource. I mean, this is basically peak backend architecture. All right, for our last section, we're going to pull back the curtain and look at the JVM's master blueprint. We're going to see exactly how all these pieces, static stuff, instance stuff, constructors, are all put together when you run your program. Seriously, understanding this is a total game changer.
So let's ask the big question. When you hit that run button in your IDE, what really happens under the hood? What's the exact step-by-step order of operations that the Java virtual machine follows? Let's find out.
To figure this out, we're going to use this one simple class, lifecycle demo. Look at it. It's got everything. A static variable, an instance variable, a static block, an instance block, a constructor, and, of course, the main method. We're about to see the precise order in which every single one of these pieces gets executed. And there it is, the output. Let's walk through this. Now, the first thing you should notice is that static variable initialized and static block executed print before main method started. What does that tell us? The JVM takes care of all the static business first. Then the main method starts, and it's only when we explicitly write new lifecycle demo that the instance level stuff kicks in, the instance variable, the instance block, and dead last, the constructor.
So why this specific order? Well, you can think of it as two totally separate phases. Phase 1 is class loading. Before main even gets a chance to run, the JVM finds the class, initializes all its static variables, and runs all its static blocks, right in the order they appear in the file. Then comes phase 2, execution. That's when main starts. And that new keyword, that's the specific trigger that kicks off the whole instance creation dance. If you remember one thing, let it be this slide right here. This is the key takeaway. The static flow runs exactly once, the very first time a class is touched by the JVM. But the instance flow, that runs every single time you create a new object using the new keyword. Understanding this separation is absolutely fundamental to understanding Java.
And this isn't just for us. The core Java libraries that you use every single day are built on these exact same principles. The string class is famously final to guarantee it's always immutable and secure. The collections class is just packed with static helper methods like sort, and the Executors framework uses static factory methods to safely manage complicated thread pools. This isn't just theory, it's the blueprint for building robust Java code.
So let's just do a super quick recap. Static means it's shared at the class level. Think utility methods or global config. Final means it can't be changed, which is perfect for something like a security token or a user's session ID. And when you put them together as static final, you get a true application-wide constant, like an API's base URL.
And that really brings us to the final thought here. Static and final. They're not just keywords you have to memorize for an exam. They are core infrastructure. They're the tools the Java language gives you to build high-performance, safe, and cleanly designed systems.
So, I'll leave you with this question. Now that you see them as the powerful design tools they are, and not just syntax, what are you going to build with them? Thanks for joining me.